Now, the first number systems that people discovered is called the natural numbers. And this kind of happens to human beings too. When we start teaching kids how to count, we don't start with 0. We always have them start with 1. And they count to 10 and they're really proud of themselves, and then they get to 100 and so on. The natural numbers are about 20,000 years old. They're about as old as our language is, which it's kind of weird to think about, that there was a point in time when human beings had numbers, but they didn't have the actual number part of the numbers. You can look at some cultures and they actually only count by saying like 1 and then many. They don't have any conception of 2, 3, or 4. And look at that, I have an error. I'm missing 2 on here. So try not to copy that error into yours. Next comes something called the whole numbers. So after you learn about 1 through 10, somewhere along the line you get the concept of nothing, of 0. And the whole numbers are all of the natural numbers, 1, 2, 3, 4, 5, on up as high as you can count, with 0 added on as well. And 0 is a relatively recent addition. It started happening about 2,000 years ago that 0 was added, but there's evidence that it might have been as much as 4,000 years old. And then we've got the integers. The integers are all of the whole numbers, 0, 1, 2, 3, and their opposites, so -1, -2, -3, and so on. So at some point in time when you're learning about math, you learn about the idea of something being negative, like I owe you $2. It's -2. And then somewhere along the line, we start to cram fractions down your throat. So the rational numbers are all of the integers, so 0, 1, 2, 3, their opposites, and any kind of fraction or repeating decimal. So if you can write a number as a fraction, say 1/4, 1/2, 2/5, or you can write it as a decimal that repeats, 0.3 repeating, 0.56, or that terminates, like 0.125, and then it ends, those are rational numbers. About 4th grade, we start teaching that to you guys, and it seems like nobody ever really likes the fractions. And then later we have things called irrational numbers. You usually learn about these in junior high. There's one that you learn about before that, though. Irrational numbers are numbers that never repeat and never end. So they go on for forever without having a noticeable repeating pattern. The most famous of these is pi, but a square root of a non-square number, like for example the square root of 2, square root of 3, square root of 5, those are all irrational numbers. Not the square root of 4 though, because the square root of 4 is 2, which is a natural number. Alright, so make sure that you got this kind of diagram in there so that you can kind of understand what's going on. Now, all of these together, so that orange box that encompasses everything, all of these together make up what are known as the real numbers. Believe it or not, there are other number systems, and we'll talk about one of those other number systems later this year, called the complex numbers, but the real numbers encompasses pretty much everything that you've learned to this point. And at this point, irrational numbers were about 1200 AD right now, so we haven't made it up to the present yet as far as math is concerned. Alright, so let's take a look at some examples and more here with this. So first, there are other number systems, many of them. We're only going to talk one more this year, and that's the complex numbers, and that'll be right near the end of the year, probably April or May. Most numbers can and do belong to more than one number system. For example, the number 2, if you were to locate that on your little planner there, or little diagram that you made, it's a natural number, but all the natural numbers are inside the whole numbers, and all the whole numbers are inside the integers, all the integers are inside the rationals, and all the rationals are inside the reals. So 2 is a natural number, a whole number, an integer, a rational, and a real. Whereas if you take a number like -1, -1 isn't in that natural box, or the natural circle. It's also not in the whole number circle. -1 is an integer, but all the integers are part of the rationals, and all the rationals are part of the reals. So -1 is an integer, a rational, and a real number. Now if I were to take something like, say, pi isn't anything that was on the right-hand side. Pi is an irrational number, and it's a real number. So every number we're going to talk about is always going to be part of the reals, and at least one other system. It's just a matter of how many other systems it's a part of. So where does -0.5 belong? Take a second, think about this, look at your chart. pause the video, and we'll come back to this in just a moment. No, seriously, pause the video. Try this on your own. All right, so since negative 0.5 can be written as a terminating decimal, or I can write it as a fraction, negative 1/2, that means it is a rational number and a real number. It's not an integer, a whole, or a natural, and it's not irrational. All right. So where does pi belong? Take a second, think about this. Pause the video. No, really, pause the video. All right, so pi belongs with the irrational and the real numbers. So here we go. These are the number systems. Now, as part of this assignment, you'll also need to know how to use a calculator, because the assignment will have you finding out what the square root of numbers are. I have a series of calculators in the classroom that you can use. If you need to know how to use the square root button on those calculators, please let me know. I'll show you. And then if you don't know how to do the square root of a fraction, let me know, and I'll show you. So there we go. That's our number systems.